All right, so we're going to look at some of your homework problems on section 2.7 of your homework. I got cut off on my last video. This only allows me to do exactly 15-minute segments, so I was in the middle of one, so I apologize for that. So I'm going to pick back up at number 12. So on number 12, let me ask it to do a similar question. We have one where we need to pick up the shape, and we need to know that this is a quadratic equation, which is the parabola shape. On this particular problem, it will not let you put the graph wherever you want it. You can try as you might, but when you click, it puts it in standard form, in the parent function basic shape. So then you've got to use these tools to move it around. So you need to know by looking over here that this -6 on the end is a vertical shift. Anytime it's an independent added or subtracted value on the function, that means it's not inside a parenthesis, it's not in a radical, it's totally separate outside the action of the operation of the x. So this is vertical, and that means a vertical shift of -6 in this case. And that is all we can do there. Let's hit save and check our answer. Let me pull the screen down a little bit so you can see down here. All right, again, I need to hit similar questions. So I did these earlier and didn't realize my recording had ran out. So on number 13, similar, we want to do a vertical shift of -1. And I thought earlier it was going to let me do just like the last one, but it's actually programmed a little differently. So it doesn't just go in standard form. You actually can pull it down one place, know that it's a vertical shift of -1, and click there as it should be. Then to make the V shape, you need to give it the right other point to aim for. Any point will do. Just don't click till you find an actual solution, another solution, by making a t-table, which means you look back at this original equation over here and you plug in something for x and get a value for y, another coordinate, and it's of your choosing. It has to fit on this 20 by 20 grid, but let's just plug in 1. If we plug in x is 1, the absolute value of 1 is still 1, and then 1 minus 1 would be y equals 0. So we have a point 1, 0. Notice up in the right hand side of that box, it tells you you've got it 1, 0. So click there and we've got it. So again, get it in the right shifting place and then give it one extra point to aim for. Then on this one, we go back to doing it the old way that we did on number 12. Oh, I need to ask it to do a similar question, don't I? Okay, so this one has multiple shifting rules. I do know that the parent equation is the x squared. It's a parabola shape, so I need to pick up that parabola. Then on this one, again, you can't pick the place you want it to go. Just click anywhere, and it draws it in standard form, and it gives you this little toolbox to shift it from. So we need to know that the -5, that's our vertical shift. So over here, we type in vertical shift -5. We need to know that this -3 is the horizontal shift, and those are always opposite signs. So that's +3, horizontal shifting, where it actually moves it away from the origin. And then the 2 is a stretch factor, a vertical stretch of 2. So again, vertical stretch is the multiplier in front of the function. And there's no reflecting. These happen when you have a negative in front of your function. It reflects it over the x-axis. If the negative is just on the x part, it reflects it over the y-axis. So we don't have that going on here. All right, and then it draws it as we typed in, and there we go. Okay, number 15, let's ask for a similar question. The square root of x plus 3, I don't know that it changed it. Maybe it did. This is a horizontal shift, so it's moved the graph back 3 places. So look for the graph that's moved back 3 places, and that's this one. Now, if there were 2 graphs moved back the same amount, you would need to then plot a point to see which one was more correct. I think on the last one I had to do that. So let's see if I can give you another example of that. Let's generate a new one. Oh, maybe it's this one I wanted to tell you about. On this one, when I did this one earlier, when I thought it was still recording, I realized that just knowing that it's a negative and a square root wasn't enough. I had to actually plot a point. So I know it's flipped upside down. It could have been this one or this one. Both of these are the square root function reflected across the x-axis. Remember, that's kind of upside down graph because of the negative multiplier in front. But I kind of had to blow this one up with my magnifier and kind of plot a point and know that this one was more accurate than down here. When I look at this one, say I plug in x is 1, and this one counts by 2, so 2, 4, 6, 8. Do note, sometimes they count by 2, so you do need to be aware of that. So at x is 1, we're really kind of right here. When you plug in x is 1, let's think about this. Back in the original function, say I plug in x is 1, the square root of 1 is 1, and then times negative 1/3. That would give you a y output of negative 1/3. So that means there should be a point on the curve over 1 for x and down 1/3. Well, on this graph at 1, it's down a lot, like 3 or so points. So definitely more than just a third. So that's how we kind of rule that one out, by how steep the curve is. You kind of have to plot a point to see that. But can you see on this one, if I go over 1, it is down just a little bit. It looks like a negative 1/3 would work for that y value. All right, let's look at another one. Okay, notice this time, again, it's the square root function, so I know it's the arc shape. This one is again turned upside down because of the negative, and the 3 affects the curvature on it. Kind of opposite from the one we just saw, so I'm kind of suspecting it to be this B graph, but let's look at it and again plot the point to verify. I know this is an upside down arc shape. If it had more on there, you could see more, but it is it looks like if I plotted a point like x is 1, let's plug in, for example, and this is arbitrary, but say x is 1, the square root of 1 is still 1, and then times negative 3 gives me a y output of negative 3. So if I went over 1 for x, that looks like it's down 3. You see, because we're counting by 2's again, so 2, that would be down 4. But at 1, it's down like just halfway through that one. So that would be, looks like 3. So that's why I would choose that graph. It's kind of between either this one or this one. These are the two upside down arcs that are, at least flipped in the right direction. And then you kind of have to plot a point and think about which one it is. All right, so I hope that helps. And then lastly, let me make a similar question. We've got the arc shape, so we do need to know that it is the graph of square root of x. It gives you kind of a multiple choice there. So you need to know your shapes. And then it asks you about the translations. First of all, the left-right translation. So this graph normally in its parent basic form is here at 0, 0. So it's been moved over, let's see, 3, 4 places. And then down, 5 places. It's been moved right by 4 and down by 5. So how do we write that? Right by 4, okay, so translated 4 units to the right, and then what does it say? Down by 5 places. Sorry, this clicking is so loud. I hear that on my video. I don't know how to make that less annoying, so forgive me. Okay, then what is that equation? So how can we then translate that from what we've been doing in the other ones? We know this is a square root function. We also know when we have a translation of 4 to the right that we write minus 4 because it's kind of backwards. When we go to the right, it's a horizontal shift. Right 4 is minus 4. Okay, then get out of your radical, and down 5 will be a minus 5. Okay, let's check that out. Since I have a little more time on my video, let's do one more of those to practice that. And maybe you all will pause the video and try your own before listening again if you need a practice of that. I always recommend that. So we have this arc function again, the square root function. So I'm going to pick that as my choice. The absolute value is the v function, so this is the arc. And then let's see, if normally it's at 0, 0, so it's been moved over 2, and that's down by 4. And don't feel bad. I always have to, sometimes you have to magnify it to see it. Oh, that's much better. Right 2, down 4. All right, so it's moved to the right. What did I say, by 2 units? and then it's moved down. We said by 4 units. So we type that in, check. And then it wants us to write the equation. Can we translate that into an equation? So pick up the square root off the toolbox. And moving to the right is a minus, opposite from what you think. And moving down is -4. All right, nice work. All right, hope that helps.